Welcome back to the Python Fundamentals tutorial. Today we're going to be continuing our lesson on lists, and we're going to delve deeper into the methods that you can perform on a list. So, starting off, I'm just going to create numList, which is a list of numbers, and I'm just going to put in whatever values I want here. And the first thing we can do is changing an item in a list. This is pretty simple. We call the name of the list, which is numList, and then we put brackets. Inside the brackets, we put in the indices, and this just has to be an integer that's actually within the indices of the list. I can pass in a variable here if the variable is an integer, and that will do the same thing as if it was a real number, and it will just look up the value of the variable. So numList0 will be the first value in the number list, and I can set it equal to 5, let's say. I can print that, and when I run this, I have this list, but with the 5 at the start, because I changed the first value to 5. Right? This also works if I did something like numList1 minus equals 45, and this will just change the value in the list. I don't have to set it equal to something, I can do math operations, right? So the second value, 64 minus 45, will give you 19. Moving on, we can insert something into a list at a certain specified index. So you call the list that you want to insert something into, and then you put dot insert, then you put parentheses. In the parentheses, the first parameter is going to be the index. So let's say index 2, and then you put the value. Now let's say I want to insert the value, just that big number, just so we can see clearly where that number is. So we can now print numList, and now look at it. We can see at the index 2, right? At the index 2, this value was inserted. So this is index 0, 1, and then 2. We put this here, and then we shifted all of the values after that 1 over. So this is like putting something in between the values 19 and 23, right? We can also append to a list. So you could do the same thing. You call the list, and then you do dot append, and then append will add a value to the list on the last index. So say 300. Now we can print numList. And we can see it's the same thing, except now there's a 300 in the last value because we appended it. Then we can also extend a list, which is a little more complicated. Let's say we had another list of, I don't know, word list. We say happy, sad, emotional, right? Let's say we had some emotions, right? So we can do numList dot extends and then put, or dot extend, and then put word list. And this will make numList what it was before, but just add a word list to the end of it. So we can see it is numList, right? And then we just added the values of word list to the end, right? You can also do this by doing numList plus equals word list, right? Let me comment this out and put this up here. And we can see that this will do the same thing. So there are two ways to do the same thing. One of them you can use a method, and the other one you can just do plus equals. You might want to do dot extends if you think someone might read your code. It might be more legible than just adding the list. Moving on, we can also remove values from, or remove a specified value from the list. So numList dot remove. Now let's say there's a certain number that I don't want in the list, like 75, right? So this will look for the first time 75 pops up, and it will remove that value. So we can see it is the list that we knew, and then we see that the value 75 just isn't there when after remove it, and everything else gets shifted up one index, okay? And let's say we try to remove a value that isn't there. What's going to happen? Like the value 0. We can clearly see that 0 isn't in this list. And we can see we got a traceback error, right? And it says value error, list remove X, X is not in the list. So be careful when using the dot remove function, because if something that isn't actually in the list tries to get removed, it will throw an error, right? So make sure that the value you're removing is guaranteed to be in the list. Now, let's say instead of trying to remove a specific value, we tried to remove something from a specific index. So numlist.pop, and let's say I don't want index 1, right? So that will be the second value. And we can see when we print that we have this, which is after we remove the 75. And now we also remove the 19, which was at the second index, or index number 1 in the second position, right? So we jump straight from 5 to this big number. Now we can also do list.clear. So numlist.clear. And this does what you think it would do. It just clears the whole list and makes it empty. So you can see the list just becomes empty, which is why there are just 2 square brackets here. This is useful if you ever want to get rid of something. So we can now move on to sorting a list. Python has built-in functions to sort a list alphanumerically, which means from least to greatest of numbers and in alphabetical order for words. So now that numList is cleared, I'm going to copy this over and reinitialize it, so we'll have all the values that it originally had. Then to sort it, I can just simply say the list dot sort, then print it out, and we can see that the list we got is in least to greatest order, right? And we can also do the same with a list of words, right? So we can do word list dot sort, word list, right? And we can see that these words are in alphabetical order. You can check that if you want to go through the alphabet. Now, what if we tried to order a list that has 2 different data types, like integers and strings, right? So we can do numList.extend word list. So now numList is all of this plus the end of here, right? Which is what we did earlier. Now we can do numList.sort. What's going to happen? Well, we get a traceback error because it says less than is not supported between instances of string and integer. So what's happening behind the scenes is Python is checking through the values, and it's trying to compare the value of a string and the value of an integer, right? And it obviously can't do that because there's no way to compare the two. So if you ever try to store a list that has a string and a number, it won't work because it simply cannot compare the 2 different data types. Now we can move on to copying lists, which is a little complicated, right? So we have numList here, right? And let's say I wanted to make numList2, okay? Equals numList, right? So let's say numList2 dot append, and I'm adding the last value from numList. I'm going to make it some big number, so it's really noticeable, okay? So now let's print numList2, okay? So what's going to happen is what you would expect, right, is numList with this big number at the end, okay? But what about numList1, or the original numList, right? And if I print that, F5, and now numList, the original one, was also changed, despite us calling numList2.append, right? We never called numList.append 300,000. We only said numList2. So why is it that when we change numList2, we're also changing the original numList? Well, that's because of how memory works in Python. When I declare numList2 is equal to numList, I'm actually setting numList2 as a reference value. So that means any change I make to numList2 is going to happen to numList. So what about the other way around? Right? Let's say I change something in numList.append. And you can see the same applies, right? So if I change either one of these, the other one will change as well. So when I set a list equal to another one, I'm essentially linking them together. And let's say you didn't really want to do that. Let's say you just wanted to copy over the values from a list, right? Inconvenience is to set numList3, right? This is a new list, is equal to and numList, the original one, dot copy, right? So this will copy over all of the values from numList and put it into numList3, right? So numList3 dot append, just put some big number in there, and then print numList3 and print numList, right? So we're printing numList3 and then the original. We can see that numList3 has the big value that we appended, and the original is unchanged, which is what we wanted, right? So that's how we can get around that little problem. Now, finally, the last thing we can do is join a list. And to do that, it's pretty simple, right? So I can have numList4 is equal to numList3 plus numList, right? And that's really it. I just print numList4. And we can see that it's numList3, which is this. And then we just appended all of the values here to the end. And that's how you can join a list. You can also do the dot extend function like we did earlier. So that's going to be it for today's video on list methods. And in the next video, we're going to go over an example on how to apply and when to use all of these different methods.